Good afternoon, my dear students. Today we'll discuss about inverted YouTube manometer. The last class we discussed about YouTube manometer. If your manometer is inverted, that is reversed, then we call it as inverted YouTube manometer, which is used for low pressures. If you are interested to calculate low pressure differences, then we'll use inverted YouTube manometer, which gives very accurate results. The accuracy of this is very high for small readings. That's why we'll use inverted YouTube manometer. So how we'll solve this problem? Same as YouTube manometer, but there are small changes. That changes we'll concentrate. Coming to the inverted YouTube manometer, here also we'll take left side and right side. This is left side and it is right limb. Coming to the left limb, so first I want to write pressures on the left limb. So if you are interested to write pressures on the left limb, what are the pressures are there in the left limb? PA. The PA pressure is there inside the limb, minus, earlier we wrote plus, because that is a direct YouTube manometer. It is an inverted YouTube manometer, minus rho g of H1 for this fluid, rho g of H1, and one more fluid is there on left side, that is manometric fluid. So rho g of M I am writing into H. Okay. Now once again listen, PA plus rho g H1 plus rho g H. That's it. Any other pressures are there? No. Now we'll write pressure on right side. If you write pressure on right limb, this is right limb. How many components are there? One is PB. So PB pressure is acting, minus, earlier we wrote plus, here minus. That was the main difference you have to observe. Rho G H2. So if you equate P left limb and P right limb, you will get what are the unknowns you have. This is the procedure we have to adapt for differential YouTube manometer. We'll solve a problem on differential YouTube manometer. So if you observe, a inverted YouTube manometer is shown in figures. This figure is saying it is used to measure the pressure difference of two fluids A and B. This is A and B, in which water is flowing. It is very clearly mentioned A and B contains a water. So whose density is how much? Density of water we know 1000 kg per meter cube. Why I am mentioning here? Because two more questions are there. Okay, which is flowing? Water is flowing. Okay, the difference of levels. This is H. The difference of levels is 0.3. So this value is 0.3, and A is 0.25. This is A, which is 0.25, and B is 0.15. This is 0.15. So he given all the values. He is asking what is the difference of pressures in the two limbs. So similar process what we solved in the last class, as well as now also we discussed about inverted YouTube manometer. For that, first I am writing in the pressure in the left limb. So this is left limb and it is the right limb for my consideration. So in the left limb, if you observe, what are the pressures are there in the left limb? That is PB. PB pressure is there in the left limb, minus. I told you already why I am writing minus, because it is a inverted YouTube manometer. That's why I am writing minus. Minus rho G into H. H is how much? 0.15. Water is flowing up to here, as well as water only flowing up to here also. So total height is water only. You can observe, because same color is mentioned. So how much total distance? So I can write directly 0.15 and take a eraser. Okay, 0.15 plus 0.3 is the pressure in the left limb. So I will now write pressure in the right limb. Pressure in the right limb is equals to, we observe, the PA pressure is acting in the limb itself, minus rho G of, here one fluid is there, above that another fluid is there. That is rho G of H. H is how much? 0.25, because the height is A is 0.25. So rho G of 0.25, which is water, plus minus rho G of H is how much? 0.3. B is 0.3. Okay. Now we'll equate both the equations. That means PB minus, what is rho value? 1000 and G is 9.81. So total it comes out to be 9810 into 0.15 plus 0.3 is equals to pressure in the A limb minus rho G is how much? For 0.25 it is water. So rho G value is 9810 into 0.25 minus rho G value is how much now? So that is manometric fluid. Manometric fluid rho G value is rho value is 13,600. G value is 9.81 into 0.3. So if you solve this equation, then you will get the difference of pressures PA minus PB. The value of PA minus PB comes out to be 38,455 Newton per meter square. Try to solve this problem by your own. Okay, then you will get a clearance. Otherwise, I'll write step by step for your understanding. I'll remove this part. So if you observe, yeah, PB minus, if you solve this 9810 into 0.45 in the calculator, it comes out to be 3531, which is equals to PA minus, if you solve this 9810 into in the calculator, you can solve this also 9810 into 0.25 and all. Then write that value here. Let me calculate how much is coming out. (9810) into 0.25, it comes out to be 0.25. Sorry, actually it comes out to be 2,452, and the value here also, if you calculate this, it comes out to be 9810 into 0.45, double 415, so minus 13,600 into 9.81 into 0.3, it comes out to be 40024. From this I can write the pressure in the B limb minus the pressure in the A limb is equals to, I am sending this A that side and this value this side, then it comes out to be 2,452 plus 40024 minus 4415 comes out to be minus of 38,061 Newton per meter square. Thank you one and all. With this I am closing today's session. I hope you will solve the remaining two problems. Two more problems are given. One is for air. So if you take air, what you have to do is you have to take density of air as 1.2041 kg per meter cube. And in case of oil, if you take, it comes out to be 0.83. We will solve oil problem in the next class. Thank you one and all.